All right, so we're on lesson 9 now. Should have erased this before I started the video. Oh no, I erased my names. Who did I have up there? I had Jonah, Ada, Alexa, Will. Okay, Jonah, Will, that's right. Ada, Alexa. Oops. Do I have anybody else up there? Anybody else made it yet? Just the 4? Okay, all right. But you're all going to be up there by the end of class, right? That's the goal. That is the goal. Chapter 9, or lesson 9. All right, so this is rules for the multiplication of signed numbers. Again, this should be reviewed, but like I said, you always find that sometimes there was just something that was missed along the way, right? And so we want to make sure that we know how to deal with these scenarios here when you're multiplying signed numbers. So a positive 3 and a positive 4, we can of course write that as simply 3 times 4, and that's just going to be 12, right? That's the easiest one. That's what we've been doing for a long time. Then we should have been doing this for a while as well. But just remember, if the signs are different, if they're not the same, then what's our end result? What's the sign going to be on our final result when we're multiplying?
Negative.
It's going to be negative, right? So negative 3 times a positive 4 is going to yield a negative 12, right? This is supposed to say 4. I don't know why I did 3 there. And then if the signs are the same, whether they're positive or whether they're negative, 2 negatives are also going to make a positive, right? So that's how these 3 scenarios would break down when you're multiplying signed numbers. It will always be, if they have the same signs, then you get a positive. If they have differing signs, then you get a negative number. All right? And so if we were to kind of chain these together, right? So if I had positive 2, and of course we don't have to write the positive. If there's no sign there, a positive is understood, right? So if we have 2 times negative 2 times 3 times 2 times negative 3. All right? And we just kind of take them in pieces, one at a time, right? We do this one first here. 2 times negative 2 gives us what? It's like this is too easy for me even to answer, right?
4.
Huh? It's going to be a what?
4.
Negative 4, right? 2 times a negative 2 gives us a negative 4, right? And so we could rewrite what's left because we've taken care of that piece, right? So now we have a negative 4 times positive 3, which is negative 12, right? They have differing signs, so we've taken care of that part of it. So we've got a 2 and a 3 left. Negative 12 times 2. I dropped my negative over here. I was like, wait a minute, this is supposed to end up all being positive. There we go. Negative 12 times 2, positive 2. Again, they're differing signs, so we're going to get a negative number, negative 24, times a negative 3. And then this last one, because they have the same signs, and our final answer is going to be positive or negative? Positive, right? And so 24 times 3 is 72, right? 72 would be our final answer there. Now you guys have, yes?
Are they always going to tell you whether it's multiplication or addition between the parentheses?
All right, let's talk about that. But I want to let me get to that in just a second. Does everybody get this though? Does that make sense? Now, you guys are allowed to use what on your test? Calculators. So I could just punch this in my calculator and it would give me a positive 72. You could totally do that, right? I'm not taking your calculators away and making you do it without the calculator. But if you don't know how to do this and you're dependent on your calculator to do this, sooner or later it's going to come back to bite you. Right? So you've got to make sure that you know how these signs work. Now, Ada asked the question about this right here. Am I supposed to always know that that means multiplication versus addition? And the answer is yes. If you see 2 parentheses up next to one another, it always means multiplication. What are some ways that we could identify multiplication? Does anybody have any other ways that we could do that?
The dot or the X.
The dot, right? So we can have a dot, and I could have my parentheses here as well and explicitly put a dot in, right? Or I could not put the dot. That would mean multiplication. The X, right? So we have something like this here, or even an asterisk. You know, I think that's what I used on one of the tests, would also represent multiplication. It doesn't have to be parentheses. it could be brackets, right? If there's no sign in between here, it will always be multiplication, okay? And if you have a number with a variable next to it, like what we talked about with pi, that means 2 times pi, okay? Can anybody think of another way? Those are kind of the main ways that we represent multiplication. But there has to be, what gets confusing with some students is this, like, well, there's a negative there, right? So when am I supposed to know this is -3 times that versus 2 minus 3? And it's, well, it's because it's inside the brackets or the parentheses, right? Even in this case here, because it's got the little symbol between it there that signifies multiplication, that tells us that we're multiplying the two together. Yes?
Do you ever have a case where there's no indication of multiplication, but there's no parentheses?
So that it just looks like this?
But it's supposed to be multiplied.
That will always be subtraction.
Okay.
Okay? So if there's no parentheses or anything, no symbols in between it, it's subtraction. Okay? If I wanted you, like some of the ways that they've written in the book, if I wanted you to think of this as 2 plus a -3, I'm going to put a plus in there. All right? There's going to be some way that I signify that. So you'll never have to guess. But if you see parentheses butted up next to one another, or you see any of these other symbols here, or a variable and a number butted up against one another, you know that it's always multiplication. Okay, thanks for asking that, because that was something I wanted to point out today, because I have seen some of you guys making that mistake, getting confused with that. Okay? All right, so let's talk about, well, how does it work? How does it work if it's not multiplication, but it's division? So what if we have, let's do this, positive 4 divided by positive 2, right? A fraction is just division, so always think of fractions as division. And so the rules are exactly the same, right? Positive 4, -2, and then the other scenario would be -4, -2. If the signs are the same, then our final answer will be what?
Positive.
Positive, right? The signs are the same in this scenario here, and the signs are the same in this scenario. So it'll be positive, right? It's almost like you could think about the negative and the negative cancel out, right? In this case, or the positives and the positives cancel out. We're just left with positive. But when they differ, then it's going to be a negative sign. Okay, so different multiplication and division works the same way. Differing signs yield a negative answer. The same signs yield a positive answer. Okay? Any questions about that? All right, so that really gets us through. They talk about inverse operations, and all they mean by inverse operations is that if I have 7 plus 3, and I'm trying to get the 7 all by itself, then I need to put a value up there that's the inverse of this plus 3, and so the inverse of that would be minus 3. All right, so that'll yield this answer of 7 all by itself. So subtraction is the inverse operation for addition, and vice versa, right? If I had 7 minus 3, and I wanted to get rid of that minus 3, I would say plus 3, and it would undo the minus 3 there, or the negative 3. And so likewise, if subtraction is the inverse of multiplication and vice versa, then what would be the inverse of, did I say multiplication? If subtraction is the inverse of addition, and addition is the inverse of subtraction, what would be the inverse of multiplication? I'll get it right in a second. Division, right? So we would say 7 times 3 over 3, and these 3's cancel out, so you're left with 7. And likewise, if we had 7 over 3, if we had 7 divided by 3, that's what that is, and I want to get rid of that 3, well then I'm going to multiply this whole thing times 3. These 3's cancel out, and I'm left with 7. So multiplication undoes division, and vice versa. Subtraction undoes addition, and vice versa. So make sure that you understand that, because that's just a concept that you use in algebra all the time when you're solving for a particular variable. Any questions about that? You guys good with that? What if I have What's that gonna be?
You have to subtract the top first and then you divide.
That's right. So I have to do the subtraction on the top first, and then I divide. What do I get on top when I do that?
0.
0. 7 minus 3 is 4, right? This is 4. And then 4 minus 4 is 0 on top, divided by 2. What's my final answer going to be? 0, right? So if I have 0 on top, it doesn't matter what I'm dividing by on the bottom. This answer will always be 0. Well, there's one exception. Sorry. Does anybody know what the one exception is? If 0's on top, it doesn't matter what you have on the bottom. It'll always be 0, except in one case.
Decimals.
No, a decimal's fine. What did you say?
Mixed numbers?
No, that's fine. What? No, that's fine too. This is the one time that it won't equal 0, when it's 0 divided by 0. And this is, we say this is indeterminate. We don't have an answer for that. And so that kind of brings me to the next thing. If I were to switch this around, and I had the 2 on the top, and I'm dividing the bottom by this, we would do the same thing. We would do the subtraction first, and we would end up with 2 divided by 0. And that's not allowed either, right? Division by 0 is undefined. Right? If you ended up with this right here and you said undefined, I'm not going to count that wrong. The point is we don't have an answer for that. Okay? So division by 0 is not allowed. That's something that you will use over and over again. I mean, I've got students in pre-calculus now that are having to remember that the 0 on the bottom of the fraction is undefined. So they're looking for something specifically that will make the fraction 0, so we can say when the problem overall is where certain values of the variable aren't allowed. And it's because they remember this rule right here, that you can't divide by 0. Any questions about that? Does everybody remember that? Can't divide by 0? All right, that should be burned into your brain if it's not. I'll bring a little cattle prod next week that says can't divide by 0, and we'll brand, not joke. Ada?
So if you put 0 divided by 0 in the calculator, what do you get?
It'll just give you an error. Yeah, so let's try and see. Has anybody, so this show, there were some funny episodes, and I finally ended up, because this one episode I saw, I was like, I don't like that. So I didn't let so my calculator says error when I tried to do that. I didn't let my kids keep watching it just because of the evolution stuff that they were weaving into it as in a kid's cartoon. I'm like, why are they doing that? But it's The Amazing World of Gumball. Anybody ever seen that? Yeah. Right. So there's this funny scene in there where the dad's like, you know how gamers will post stuff online, how they're playing the game and all, and they're kind of reviewing the game or whatever, or they're showing you how they did something in the game. So it's a scenario like that. So he's showing the game on his. He's like, I found this other game besides Minesweeper or Solitaire or something on the computer, and it's called Calculator. And so he's doing the calculator, and he's got it all worked out. He's like, first you take the arrow and you do this, and then you find the treasure because X marks the spot. He says all this stuff, and then he's like, but if you don't want to use the something with the balloon, and so he basically divided by 0 when he does that. The calculator blows up. It's funny. I don't know why I told you guys that, but I did. So anyway, we'll keep moving along. So division by 0, your calculator is going to say that's not allowed. It's going to give you some sort of error. I don't think it's going to blow up, but according to Gumball, Amazing World of Gumball, it will. Multiplication is what we call commutative. So the commutative property of multiplication says that 4 times 3. When I say that it's commutative, you know what I would write next to show that multiplication is commutative? Does anybody know?
You flip 3 up there.
Flip them around, right? So with multiplication, it doesn't matter the order that you do it, right? So you can always flip those around and you'll get the same answer. So again, that's one of those little nuggets of knowledge that somewhere along the way you missed that rule. Because that's what a lot of this stuff is, right, early on. It's just there's a whole set of rules that if you use them enough in math, they come automatically and you remember it. But you know, if some of you may be like still, you see something like this, and And you're like, oh, I gotta multiply the 24 times the 3 right off the bat. No, you could multiply the 3 times, you could jump totally out of order and say, I'm gonna do it like this, because it's easier for me to think about it like that, right? It doesn't matter what order you multiply numbers together. If you're just multiplying all of them, you can reverse that order. The last thing I told you guys that there was something that with the second problem on the test, we were gonna kind of go over that type of problem. This is the quiz that I just handed back to you guys, right? So that particular quiz, I don't remember what the problem was. Maybe it was like, what is 3.2 feet in centimeters? I did something like that, right? Something like that. And so this is where we use unit multipliers. In other words, values that are equal to one another with differing units, right? And so for this problem here, what are the unit multipliers that we're going to use?
Feet, inches, centimeters.
Say it again.
Feet, inches, centimeters.
Feet, inches, and centimeters. So some of you just totally ignored the inches part, right? You tried to go straight from feet to centimeters, and we don't have that conversion relationship. What we do know is that 1 foot has how many inches in it?
12.
12 inches. And did I give you guys on the quiz how many centimeters were in an inch?
Yeah.
I think so, right? That one's a little less commonly known, but there's 2.54 centimeters in 1 inch. Okay? And so when we go from feet to centimeters, we don't go directly from feet to centimeters. We go from feet to inches, and then we go from inches to centimeters. And that's how we get our answer. So you have to convert it in that order, right? And so we would say 3.2 feet times, I'm going to write it out like this, and I'm going to write it the way that I probably wrote it on your quiz if you missed it, and the way that I also showed you guys in class. I'm going to do 3.2 feet times this, a unit multiplier that's based on that relationship. So the unit multipliers will always have one of these values on top and the other value on the bottom. If I'm going from feet to inches here, what am I going to put on top?
12.
I'm going to put the 12 inches. I want to put inches on top because that's the unit I want to end up with. And I'm going to put 1 foot on the bottom, right? Cross out the 2 feet. I can cross out the feet. So this is, and you guys remember, you can always kind of think of that as being over 1 if you want to make sure that you know what you're multiplying together. So we've got 2 fractions here. Anytime you've got fractions multiplied by one another and you've got something on the top and something on the bottom that's the same, you can cancel those out. So by writing it like this, it's very clear that feet is going away, and I'm going to end up with a unit that's inches, right? So I can punch that in my calculator, and wow, I'm not sure. So what that would end up, something bigger than 36.
I think it's 97.5.
That's the final answer, right? So what is this one here?
38.4.
What is it?
38.4.
38.4. 38.4 inches. Okay. Now I'm to the inches, and I'm ready to go on and get my centimeters value, which means I can use this conversion relationship. So the unit multiplier that I can use now as I go from inches to centimeters, am I putting centimeters or inches on top? Yes. Centimeters or inches go on top?
Centimeters.
Centimeters have to go on top because inches need to be on the bottom so that they'll cancel out, right? How many centimeters are in an inch? According to this relationship here, 2.54 divided by 1 inch. And so, again, we're just multiplying. We've got numerators and denominators. We multiply the numerators together to get the top number. And somebody told me it was like 70 what?
97.5.
97, that's right. 97.5 roughly is what that turns out to be centimeters. And that's our final answer. Okay? Now I showed you guys last time that I like to do it like this, which is fine as long as you realize what we're doing is we're just doing multiplication and division when we do it like this. So I like to chain all of this stuff together. Does everybody see this is the same thing as what I did in 2 steps here, right? 33.2 times 12 over 1. And then whatever the result of that is times 2.54 over 1. That's what I've written here. And so what this allows me to do by doing it like this is to see very clearly that feet cancels out here, inches cancels out here, and I'm left with centimeters. And so everything that's on the top, I'm going to multiply together. If I'd had a number besides 1 on the bottom, I would divide by that number. Okay, so this one is actually, and they'll do this in the book, it's 3.2 times 12 times 2.54 with a unit of centimeters. They'll do it like that in the book, and they'll just leave it like that. They won't actually multiply it out, because they won't, and I won't. I want to see clearly that you understood I was multiplying all these together to get my final answer. Okay? So that's actually, for these unit conversions, that's sufficient. You don't have to do any other, you don't have to punch anything else in your calculator. Just show me that you knew how to, what gets multiplied together to get the final answer. Does that make sense? Okay? So that's how you do a simpler one like this. Now they complicate things a little bit more, and they say, well, what if we don't have the basic units? What if we don't have just feet? What if we don't want to go from feet squared to centimeters squared? Great. Really? You had to go there.
Would it not just be the same thing?
It wouldn't. So that's why wouldn't it be the same thing? What do we have to do differently? And so this is what we have to realize, that when we've got we have to realize in something like this that we've got let's see how it would differ. So I'm gonna leave this thing down here so we can see when we were just going from feet to centimeters what it would be. But now we've got 3.2 feet, and it's not just feet, it's feet times feet. Does everybody see that? And that's feet squared. Feet squared is feet times feet. And so if I want to get rid of my feet, I'm using the same conversion relationships here. I'm still saying that 12 inches equals 1 foot. But if that's all I have, all that cancels out is one of my foot units, right? I'm going to have this twice now. So I'm going to use this unit multiplier twice, and now I've gotten rid of all of my feet. If I stopped right there, what would my resulting units be? Huh? No, not quite. Inches squared, right? Did Allison, did you say that? Yep, inches squared, because it's inches times inches, so it would be inches squared. So if I stopped right there, I would say my answer is 3.2 times 12 times 12 inches squared, right? We're not trying to find inches squared, we're trying to find centimeters squared. So we're actually not done yet. So we're going to, now that we've got, all right, we've converted to the inches, now we're going to use the same relationship we used here, but I've got 2 inches that I need to get rid of. 2 inch units, so I'm going to multiply by that twice. So now this inch can cancel out with that one, this inch can cancel out with that one, and so my final answer would be 3.2 times 12 times 12 times 2.54 times 2.54 centimeters squared, right? Because the centimeters didn't cancel out. So I get the final units that they were looking for. Did I blow anybody's mind with that? Did I lose anybody? Does that make sense to everybody? We're going to do another one, but I just want to make sure that you don't have any questions about this before we do something that'll end up being a little bit more complicated, only because we won't have just numbers we're multiplying together. We'll have some numbers we're dividing by. Any questions about that? So the problem that they have in the book is that we want to do 44 inches squared, and we want to convert to square centimeters. 44 inches squared. No, that's not the one I wanted to do, sorry. 125 square centimeters. 125 centimeters squared. and convert that to square feet. All right. So who wants to help me with this? Is anybody that's not on the board? Is anybody not on the board want to come up here and work this problem for us? No? Guys, the 7th graders that I teach are more excited about doing this than you guys are. You guys gotta help me out, all right? They're all like, oh, pick me! All right, fine, I'll do it. Can you just kind of help me? Huh? So yeah, you guys tell me what I got to do. So I'm going to start off with 125. I'm going to write it like this, so it's clear to me, right? That I've got centimeters times centimeters there. So that makes it clear that I'm going to have to cancel out multiple centimeters. So where am I going? I'm going from centimeters. I got to go eventually from centimeters to feet. But I don't have a relationship between centimeters and feet, so what do I have to have in the middle?
Inches.
I have to have inches, right? So I'm going to use this relationship here. What unit do I want on top, and what unit do I want on bottom?
Centimeters on bottom and inches on top.
Centimeters on bottom, because if they're on the top, they're not going to cancel out like I need them to. So I'm going to put inches on the top, centimeters on the bottom. So 1 inch equals 2.54 centimeters. Let me write that a little closer together so we'll have enough room for this whole thing. 1 inch equals 2.54 centimeters, right? So that's going to cancel out with one of those. Since I see that there's another centimeter left, I'm going to have to do that again, right? 1 inch, 2.54 centimeters. So that'll cancel out with that. All right, someone not on the board, tell me what I'm going to have to do next. What conversion relationship am I using next? Can you just answer that question for me? Someone not on the board.
Division.
What?
Division.
Who said that? Oh, Cohen, division? Explain what you mean by that.
Dividing the 125 by the 2.54 twice.
Okay, so yeah, so this is going to end up being division. He's absolutely right about that. So that's good to point out, and we'll see that at the end. And it's important that you guys understand when we're constructing it like this, it means all of this stuff on top is multiplied together, and we're dividing by everything that's down here, okay? But what my question was actually is we've got some more unit multipliers that we need to use here. So what's the next relationship I'm going to have to use in order to get to our final goal of feet squared? Madeline?
Is it feet?
So we need to have feet in there. Feet and what?
Inches.
Feet and inches, right? Do you guys see that? Does everybody see that? Because inches is what we have right now. We've got to get rid of our inches and convert it to feet. So Madeline, is feet or inches going to go on the top?
Feet's gonna go on the top.
Feet, that's what we want to end up with. And it makes sense that inches will go on the bottom because that's what we want to cancel out, right? Because we've got inches on top right here. And we're going to have that twice because we've got 2 inch units, right? And so now we look back here, we see that 1 foot is equal to 12 inches. 1 foot is equal to 12 inches. Our inches now all cancel out. And so what is our final answer going to be? Not punching it in the calculator, but just writing it out as a fraction. What's the number that we have on top?
125.
Just the 125, right? There's nothing else. On the bottom, though, we've got a 2.54 times the 2.54 times 12 times 12. And then all of that there is going to be, what's my final unit? Feet times feet. So it's just going to be feet squared, right? Does everybody see that? All right. We're out of time, aren't we?
Yeah.
All right, so we're done. That's it. We only made it through chapter 10, no problem. I'll hand out the test next week and we'll review for that, all right? You guys have a great day.